I'm going to be reading from the geography textbook, page 116 to 118, Physical Conditions for Agriculture. Climate, soil, and natural vegetation are important physical requirements for producing food. People have shown that they can overcome environmental obstacles, for example, by using canals to bring water to dry land. However, the earth itself has a strong impact on successful agriculture. The effect of climate. Long term weather conditions are tied to farming in two ways. Climate is the main agent that creates the soil. A favorable climate is necessary for plants and animals to flourish. The map of world climate regions below suggests which areas may be suited for farming and which are not. Water, ice, and wind create the eroded sediments that form soil. Heavy rainfall and tumbling streams steadily wear down rock faces. Some rocks, such as limestone, are broken down by water. And I'm just going to pause with the reading a second to look at this map. So this map, we've got the whole world there, and you see at the bottom there are a whole bunch of different climate types that you can see. So where we live up here, we have cold winter. Yes, we do. And you see just above that, we've got the polar climate, the tundra and stuff where it's very cold and dry above. We've got the warmer tropical areas near the equator. We'll continue reading here. When water in rock crevices freezes, it acts as a wedge, splitting the rock. A moving glacier works like rough sandpaper as embedded rocks beneath it grind over the land. Wind is important too, sandblasting rock faces with flying bits of sand and grit. Climate causes the forces of erosion that produce soil. Over here on the right, we have a kind of a soil sample cross section. We've got the top decomposing material, mostly plant material that has accumulated in the past months. Underneath that, we have humus, a dark layer of organic material from the decay of previous generations of leaves and plants. And then underneath that, we have horizons. So there's the A horizon and the B horizon here, layers of different materials within the soil profile. Lower horizons contain less humus materials than the upper horizons. And down at the bottom, we have parent material, broken down rock material in the base of the soil profile. Two definitions here. There's soil profile, a cross section of the upper layers of the Earth's crust, and permafrost, permanently frozen ground. The effect of soil. Most soils have different levels from top to bottom. A soil profile is marked by horizontal bands of color, which generally become a lighter brown with increasing depth. The general rule is the darker and thicker the upper soil layers, the greater the soil fertility. In polar and cold continental climates, soil profiles have a thick layer of permanently frozen ground. This is called permafrost, and it severely limits the depth to which plant roots can reach. As a result, the natural vegetation in these tundra regions is mostly low shrubs and summer flowers. And what we see here is a map that has all the different types of soil. If you were to kind of look at those two maps together, like they are in your book, side by side, you can see that there are definitely some similarities between where different regions are. And then page 118, the effect of natural vegetation. Natural vegetation is the trees, grasses, and other plants originally found in an area. Often it has been cleared away for roads, buildings, and farms. The pattern of natural vegetation found in a region resulted from the interaction of landforms, climate, and soil. Aboriginal peoples and pioneer farmers often used these plants to predict the suitability of an area for crops. Natural vegetation has an important effect on soil fertility. Decomposing leaves, grasses, and needles produce the soil's humus layer. Natural grasslands and broadleaf forests drop organic material, resulting in fertile agricultural soils. Coniferous trees do not produce much organic material. Their needles are acidic, leaving the soil with limited fertility. You might expect thick tropical rainforests to have rich soils beneath them. Unfortunately, heavy rainfall carries most of the nutrients very deep into the ground. Tropical soils are often poorly suited for anything but shifting cultivation, a type of temporary farming that will be described later in the chapter. We see here shifting cultivation, a type of temporary farming practiced by indigenous farmers in the rainforest.